Today we have Chapter 1, Section 4, Graphs of Proportional Relationships. The content objective says students will analyze the relationship between two quantities graphed on a coordinate plane to determine their proportionality. Suggested pacing says this is a 135-minute long lesson. It may take us 3 days in the classroom to get through it, but we're going to do the best we can right here. Needless to say, there's going to be more than one video associated with this section. From here, we're going to have some good news in that you do not have any new vocabulary in this lesson. Everything that we're going to talk about, we've already used before. So no new vocab words to write down and learn. Instead, we just get to talk about some lady mowing her grass here. Graphs of proportional relationships. If you have a job, your employer may pay you based on the number of hours you work. In this case, the total amount of money you earn is proportional to the total number of hours you have worked. If you think about the graph here, it shows the relationship between the number of hours worked and the total amount earned. You can use a graph to determine how much is earned in 10 hours. On your horizontal number line or your x-axis, you have time. On your vertical number line or your y-axis, you have your amount earned. And you can see in 1 hour, $10 was earned. 2 hours, $20 was earned, and so on up, making a linear graph. And you can calculate up however much you want using the graph based off the number of hours earned. Holy cow, I just looked at how many resources we have for this one. There's 17 resources in this lesson. I think that's the biggest lesson I have done between 7th and 6th grade so far. So, moving forward, you're introducing the inquiry question. How are the graphs of proportional and non-proportional linear relationships alike? How are they different? You're going to use a web sketch pad to explore this problem. That sounds like fun. And on the right it says, Albert, I think we should have 10 minutes more for recess. I agree, Albert, but what about lunchtime? You're both right, but I think we need more time to study our subjects. That must be the teacher or the class nerd talking. I love class nerds, by the way. And finally, David says, I like the way Albert and Bianca think. However, what we really need more of is summer vacation. I'm totally into that. Why they included all that for you, I have no idea, but hey, I read it to you anyhow. Moving forward, several of the students in Miss Brown's class joined an online discussion group. Each student posted 4 comments. The number of replies to each of the comments is shown in the tables. Drag the correct ratio in simplest form into the tables to find the ratio of the number of replies to the number of comments for each student. Pause the recording while you do this and then check your answers. Did you find the trick question in here? The trick question said find the ratio of the number of replies to the number of comments. They flipped it on you. They gave you comments over replies. They want replies over comments. So we've got, when we look at that, that one's can become a 2 over 1. And it says the simplest form into the tables, all right? So that one is going to be 2 over 1 again in simplest form. That one's going to be 2 over 1 again in simplest form. And that one's going to be 2 over 1 again in simplest form, because 4 over 8 simplifies to 2 over 1, 6 over 3 simplifies to 2 over 1, and 4 over 2 simplifies to 2 over 1. Now remember, the reason we flipped it is because they changed the order up here in our instructions. Check our answers. All of them are correct. They set you up for failure, but you guys, I'm sure, were smart enough to avoid it. Or at least I hope you were. Moving to the next slide. Drag each student's name into the appropriate bin to determine if the relationship between the number of replies and the number of comments for each student is proportional or non-proportional. Once again, I want you to take and pause the recording. This should be a review from what we've done on the previous lesson, and you determine who's proportional, who's non-proportional. I just realized that we had more problems here that we didn't answer. We got to do all these fine youngins. So Connie, we've got right here a 1-to-1 ratio, and then we're going to have a 5 to 2 ratio. We're going to have a 3 to 9, excuse me, 9 to 3, also known as a 3 to 1. And then we got a 13 to 4, which is lowest terms. Check that answer. Next, we've got to look at Bianca. Bianca has a 1 to 1 to start with. A 4 to 2 becomes 2 over 1. 7 over 3 is in simplest terms. And 10 over 4 becomes 5 over 2. Check that one. And finally, David is going to become a 3 over 1. 6 over 2 also is a 3 over 1. 9 over 3 also is a 3 over 1. And 4 over 12 also is a 3 over 1. All those are checked, and now we're better prepared to answer the next questions. Now, Albert had a constant rate down here. We called that a constant of proportionality or a constant ratio the other day of 2 over 1. So Albert goes in the proportional box. Connie did not have a constant of proportionality or a constant rate of change here, so Connie goes in the non-proportional box. Bianca also did not have a constant rate of change, so she's non-proportional. Meanwhile, David did, so he is proportional. So Bianca goes right, David goes left. Check our answers. All of that is good. Now we're going to learn how to use a sketch. So first slide, we're going to take and graph points on the coordinate plane by selecting the dot. After we select the dot, then we're going to drag it to where it needs to go. Press the Show the Tables button to show the data for each student. You can see the Show the Tables button right there. And then use a sketch pad to graph all of your points. After you graph the points, press Show Graph button to show the line for each student. So now we are ready to go. We're going to start off with show all the students. So first thing we're going to do is come up with Albert. So for Albert, he's going to start off with a 2 over 1. So we're going to take and have the number of comments over 1. Let's make sure I did that right. We were comparing the ratio of, replies to comments is how we did that. So, number of comments to replies. So, replies to comments. So, replies are going to be the 2, and the comments is going to be the 1. His next one is 4 over 2. He's going to add another dot, and we're going to run 2 and rise 4 because the bottom number is going to be our x value, the top number is our y value, and then we have 6 over 3. So we're going to take and run 6, rise 3. Rise 6 and run 3, which is going to put us right there. Our last one for him is going to be an 8 over 4. Add another dot. That means that we're going to run 4 and rise 8. And if we select to show Albert's graph, boom, you can see a line of it. You pause the recording and you make the graphs for the other students. See if you get it done right. Alright, I made up my graphs, and as you can see, it created quite a mess of dots. But if we were to start adding the graph lines here, you can see there's Bianca. Bianca goes through 4 dots. Next we have Connie. Connie also goes through 4 dots. And finally we have David's, and David also goes through 4 dots. Each one of these graphs is a linear graph, but that doesn't necessarily mean that each one of these graphs is proportional. You have 2 that were proportional and 2 that weren't. Do you notice anything about the 2 that were proportional? Our proportional graphs were Bianca, the blue one, and Albert, the darker blue one. And down here we can see that Bianca is going to be blue and Albert is green. So if we look closer, what do we see about the green and the dark blue one? They both go through the origin. If you have a proportional relationship, the graph is always going to go through the origin. If it's not a proportional relationship, it won't go through the origin. It's simple as that. And with that, I gave you enough information that you can answer your inquiry question here. How are the graphs of proportional relationships and non-proportional linear relationships alike, and how are they different? Pause the recording, put in your answer, and then check the sample answers. Alright, the textbook said the graphs of proportional and non-proportional linear relationships both make straight lines. We talked about that. But only the graphs of the proportional linear relationships pass through the origin, also known as point 0, 0. We talked about that as well. Now we want to consider the two graphs shown. How can you determine if a relationship is proportional from a graph? Well, we just answered that question. Select each card to check your answers. As you recall, we said that if it was proportional, where is it going to go through? What one point does every proportional graph go through? The proportional graph is, of course, going to be the one that goes through the origin. That's going to be this one. The non-proportional graph is going to be the one that is still a straight line because it's a non-proportional linear graph. However, it does not pass through the origin, making it that one. So the left is proportional, the right is non-proportional. Move through the slides to analyze each graph and determine whether it shows a proportional or a non-proportional relationship. You pause the recording and do this part on your own. Alright, so is this graph going to be proportional? The answer is going to be yes. It's a straight line and goes through the proportion, through the origin. Check it. Good. Is this graph going to be proportional? No. Although it's a straight line, it does not go through the origin. How about our next one? Is it going to be proportional? Well, it goes through the origin. However, it is not a straight line, non-proportional. And finally, is this last graph going to be proportional? It is a straight line. It does go through the origin. It is going to be proportional. Easy math. Anybody can do these things once you learn the rules. Now it looks like we have a race between the rabbit and the tortoise. The table shows the distance that the tortoise moves after 0, 1, 2, and 3 minutes. Determine the number of feet the tortoise, whether the number of feet the tortoise moves is proportional to the number of minutes by graphing the relationship on a coordinate plane. How will the table help you to graph the relationship? Well, you have an x column and a y column. That should help you to get this done. So you take a minute, pause the recording, graph the relationship, and check your answers. So I did mine, and when I graphed it, I got these 4 dots here. And if you were to take, you could add a pen tool here and select those 4 dots. You're going to see that they do indeed make something that resembles a straight line. Now, my line wasn't very straight, but you kind of get the point. I think I could, however, grab this. Oh, and I have no idea what that's supposed to do or why it worked, but here we go. We're going to grab one point here, grab the other point, and stick it right there, and lo and behold, check that out. Isn't that cool? We got a straight line. Pretty neat toys they give us to play with. Check our answer, and the answer is indeed going to be correct. Once again, you need to pause the recording and answer these questions. Check your answers. Did you do it? So the relationship is proportional because the line is straight and it passes through the origin. Check your answers. Both parts are correct. If the graph of a proportional relationship must be a straight line through the origin, how does the table illustrate the same information? Well, if you think about the table allows you to take and put in number in a nice chart how things are going to end up being graphed. The table gives you your x and your y points. Then you have to take those x and y points and put them on a graph to show what it actually looks like. Once again, I would like for you to pause the recording and work this problem. The cost of 3D movie tickets is $12 for 1 ticket, $24 for 2 tickets, and $36 for 3 tickets. You're going to graph the information. After you graph the information, you're going to answer the questions below here. go ahead and pause the recording, and I will make it a little bit smaller in case you don't have access to it online, so there you can see everything you need to know. Do that. So when I graphed it, it gave me a straight line, as you can see here. It goes through the origin. The relationship shown is going to be proportional because the graph is a straight line and it does pass through the origin. Check our answers here. That one, is that incorrect? Shouldn't be. And this one here is correct. Let me figure out what the issue is on this one. Well, my answer was actually correct. I don't know why I was judging it wrong, but when I clicked on the show answer, that's what I ended up getting. So the answer I have is correct. My answer is right there. It's the same exact thing. So I'm not sure why they marked me wrong for that. We're going to end part 1 here. Come back to watch part 2 of these terribly exciting videos on graphs of proportional relationships.